Students, today we will discuss about inelastic collision in one dimension. So, during inelastic collision, linear momentum is conserved, but kinetic energy is not conserved. For example, when a bullet fired from the gun and that is embedded into a wood, and both the objects, bullet and the wood, moving with the same velocity, and that collision is called perfectly inelastic collision. So here we show there is a loss of kinetic energy during the inelastic collision. So consider this is a body having a mass m1 and moving with velocity u1, and here there is another mass m2, and this object is at rest. So before collision, this is before collision, and after collision both moving with the same velocity. So you know, during inelastic collision, linear momentum is conserved. So linear momentum before collision, that is equal to m1 u1 plus m2 into 0. So that will become m1 u1. Linear momentum after collision, that will be m1 v plus m2 v. So that is your v. So during the inelastic collision, you know, linear momentum is conserved. So it means initial momentum is equal to final momentum. So we have m1 u1 is equal to m1 plus m2 into v, and v is equal to m1 u1 upon m1 plus m2. This is equation number 1. So this equation 1 is a common velocity where the two objects are moving. Okay. Now we show here that the kinetic energy, there is a loss of kinetic energy during inelastic collision. So kinetic energy initial, that is equal to half m1 u1 square. You know, u2 is 0, and kinetic energy final is equal to half m1 plus m2 into v square. We put here the value of v, so we get half m1 plus m2 into v square. So m1 square u1 square upon m1 plus m2 ka square. This will cancel out. So we have to show that kinetic energy is lost here. So initial minus final, that will become half m1 u1 square minus half m1 square u1 square upon m1 plus m2. So common is there, half m1 is common, and u1 square is common. So we get 1 minus 1 upon m1 plus m2, that is equal to half m1 u1 square, LCM is here, m1 plus m2, and we get m1 plus m2 minus. Okay, see here, when you common here half m1 u1 square, there is a square, so we get here m1 also, m1, so here comes m1. So this cancel out, and we have the final result, that is kinetic energy initial minus kinetic energy final, that is equal to half m1 m2 u1 square upon m1 plus m2. And what this equation shows, the masses are always positive, and the square of the negative is also a positive. So kinetic energy initial minus kinetic energy final always greater than 0, and that means kinetic energy initial greater than kinetic energy final. So it means there is some loss of kinetic energy during the perfectly inelastic collision. So this equation shows the article perfectly inelastic collision in one dimension. So I think clear.